Okay, people, we're going to have this is going to be a video that combines taking notes about acceleration, but also learning what acceleration is. Um, so what I'm going to do first is I'm going to just go ahead and I'm going to do a Logger Pro video motion track for a runner that's running a 40-yard dash. And I'm going to do it fast. You guys aren't going to have to do this. You're just going to watch me do it um, so that we have something to look at. Because if we don't have anything to look at, then this can be pretty boring. All right, so I've got Abe Chavez here. Some of you guys might know him. Abe is going to run a 40 for us. All right, hopefully he gets started at some point. All right, hand up. There he goes. Okay. All right, so I'm going to track his motion. We'll just do, let's see, what do you guys think? We'll do every 10 frames. 10 frames after adding a new point. All right, so I'm going to wait for him to start. There we go. He's moving forward. So we'll put a dot on his head. Moving forward. Okay, now when we start off, notice that the dots are pretty close together. Now, as he speeds up, we're going to see that the dots are going to get spread out farther and farther. So when the dots were close together, that indicates that he's moving slow. And then the farther that the dots get spread apart, the faster he's moving. And I'm going pretty quick here, so hopefully this all turns out okay. Hopefully Abe has like not a too embarrassing time, but that should just about do it. Okay, so he's running the 40-yard dash here. I'm going to go ahead and I'm going to measure out from where he started, right about there, to where he finished, right about there. We're going to tell it that that is 40 yards. We'll do it like that. And then finally, we'll tell it that it's the starting point right there. And, oops. So we'll go like that, and we'll angle it so it's just in line with the green, right? Oh, so close. There. Perfect. Okay. So that should do it for this. I'm going to go ahead and I was moving side to side, so I'm going to make it X. You guys can watch me insert a graph. I'm going to make it X velocity. Okay, so we've got now, we show his speed here where it's pretty flat is slow, but gradually it gets steeper and steeper until it gets pretty linear here once his speed level's off. And we can see that here too. His velocity is really low down here, you know, like 1.5, 2 yards per second. But he rapidly increases his speed here. And then he sort of levels it off right around like 9.5 yards per second. So what I'm also going to do here, guys, is I've also got a Pages document. So I'm going to give notes here. Now you can type your notes if you want. You can also write them handwritten. I don't really care, but I do want you to take notes because there's going to be questions as we go along. So today we're going to learn a new term, acceleration. And let's just make, just in case here, make everything bigger like that. All right, so acceleration. So here is going to be our definition of acceleration. The rate of change of velocity. All right, so if we think about that, that means how quickly velocity is either increasing or decreasing. So we'll do like another way to say it, AKA, how quickly an object is speeding up or slowing down. So we know that just like velocity isn't the only thing. When we look over at Abraham, like we don't want to just know his top speed in this section of the run. We want to know how quickly he gets up to his maximum speed. So we're going to be able to find acceleration based on these graphs. And let's also put in here, so we'll do like acceleration, we'll underline that. How about AKA we like, wait, here's what we'll do, we'll indent that. And then let's do like the usefulness of acceleration is this. Lets us compare how different objects change speed. So specifically in this unit, we're going to look at runners. We're going to look at people, guys and girls, running 40s. How do they compare in this initial section? So, you know, if we're not so concerned about their top speed, but we want to see in this very beginning part right here, who is speeding up the fastest. We can compare that by using acceleration. So let's do another section here. So how to find acceleration. All right, and so the biggest way that we're going to do it is going to be to find the slope of the time versus velocity graph. So let me show you how that works. So when I go back over here to Logger Pro, notice I've got my time versus velocity graph here. Now, finding the slope of this graph up top just tells me the velocity, which I already know down here. Now I want to know the acceleration. The slope of this graph will tell me the acceleration. Okay, so if I can find slope, I can tell the acceleration. Now you guys did in your video yesterday, some of you are finishing it today, that's fine. We can use this tangent tool right here. And what it will tell me is the slope at any point on this graph. So what I can tell is right here, and we'll make that nice and big. All right, so I can tell that in this section where he is speeding up, the slope is the acceleration. So the acceleration is 4.059 yards per second per second. Let's write that down, okay? So if acceleration is what did I say? 0.59. 0.59 yards per second per second. That means the speed is increasing by 4.059 yards per second, every second that goes by. All right, so his acceleration at that exact point is 4.059. So he's speeding up at a rate of 4.059 yards per second. Now what we can do is we can say, all right, Abe, that's good. Let's see, is that the highest? So as we go along, 4.4. So look at that, right at the beginning, there's his highest. So he had an acceleration at one point of 4.495 yards per second. What we can do is we can go back and we can look at other runners and see if other runners have an acceleration that big. And we can compare Abe's ability to speed up to other people's ability to speed up. And then later on, we'll also compare how things slow down. So that's what we're doing with acceleration. We're comparing, okay? Here it is. Lets us compare how different objects change speed. So that's the whole point of acceleration. So make sure you have this stuff written down. There's going to be questions throughout this thing, so make sure you answer all those questions. And then I'll be back tomorrow so we can talk about all this stuff some more. All right, thanks for watching, guys.